Maybe we really can use black holes to travel the universe.
Section 51.
Section 51.
Section 51.
Hi everyone, what's up? I am GH, aka DOZgeek, back here with you and section 51. Thank you again to watch this new video. Scientists have been looking into black holes since 1783, when scientist John Mitchell first proposed the idea that they were possible. And after all this time, they were still a mystery in many ways. Black holes are also infamous for being photo shy, but since April the 10th of 2019, history was made and all that is about to change. As their name suggests, black holes are invisible to the naked eye. Theorized points of infinite density were beyond a critical radius known as the event horizon. No light can escape. So how is the invisible now visible? Well, firstly, it should be noted that although not directly visible, their overwhelming presence can definitely be seen. These enormous cosmic objects have a huge gravitational pull which distorts space-time and superheats the surrounding material. So it is these effects that can be observed. For example, in a binary system consisting of a black hole and a companion star, the black hole will accrete matter from the companion star. If the accreted matter has sufficient angular momentum, it will not succumb to the intense pull of the black hole and will instead form a disk, an accretion disk. It is this matter that can be seen, which also revealing it was just not revealing enough. However, Einstein's theory of general relativity predicted that if the surrounding material is bright enough, then the black hole should create a shadow which could be observed. Such an observation would require an extremely high resolution, of which had never been done before. Moreover, the theory of general relativity predicts that a sufficiently compact mass can deform space-time to form a black hole. The Event Horizon Telescope project, therefore, set about trying to achieve this. Utilizing a global collaboration of 8 radio telescopes, one of the greatest telescope arrays was created. On April the 10th of 2019, those efforts have paid off and the first image of a black hole has been obtained. Amazing pictures of a black hole for the first time in the human history. Located 53.49 million light-years away at the center of the Messier 87 galaxy, the whopping 6.5 billion solar mass black hole M87 was successfully imaged, providing the first direct visual evidence of a supermassive black hole and its shadow. The telescopes contributing to this result were ALMA, APEX, the IROM 30-meter telescope, the James Clerk Maxwell telescope, the Large Millimeter Telescope Alfonso Serrano, the Submillimeter Array, the Submillimeter Telescope, and the South Pole Telescope. Petabytes of raw data from the telescopes were combined by highly specialized supercomputers hosted by the Max Planck Institute for Radio Astronomy and MIT Haystack Observatory. The construction of the EHT and the observations announced today represent the culmination of decades of observational, technical, and theoretical work. This example of global teamwork required close collaboration by researchers from around the world. 13 partner institutions worked together to create the EHT using both pre-existing infrastructure and support from a variety of agencies. Key funding was provided by the US National Science Foundation, NSF, the EU's European Research Council ERC, and funding agencies in East Asia. The image shows a bright ring formed as light bends in the intense gravity around a black hole that is 6.5 billion times more massive than the Sun. This long south image provides the strongest evidence to date for the existence of supermassive black holes and opens a new window onto the study of black holes, their event horizons and gravity. At the center of the black hole is a gravitational singularity where all matter is crushed into an infinitely small space. The black hole lies 55 million light years away from us. It is around 100 billion kilometers wide, larger than the entire solar system and 6.5 billion times the mass of our Sun. Through creating an image of a black hole, something previously thought to be impossible, the EHT project has made a breakthrough in the understanding of black holes, whose existence has long been difficult to prove. The image will help physicists to better understand how black holes work, and images of the event horizon are particularly important for testing the theory of general relativity. Now, here are 5 things you probably didn't know about black holes. 1. Black holes used to be stars. Stars live a very long time, but just like us, they don't live forever. They slowly burn through the fuel that keeps them shining. When they run out, one of 3 things happens, mainly depending on its mass. The star will transform into a white dwarf, a neutron star, or a black hole. If the star is big enough, say 10 or 15 times as weighty as the Sun, it will explode when it reaches its end. The explosion causes the star to cave in on itself, decreasing its size dramatically. Because the size of the star gets smaller but the mass of it doesn't, the gravity surrounding the star becomes so strong it absorbs everything around it, including light, and a black hole is born. 2. There are 3 types of black holes. Primordial, considered to be tiny, these range from the size of a single atom to a mountain. Mountains probably don't seem tiny to you, but space is a mighty big place. Stellar. These are the ones most often found. They are about 20 times bigger than the Sun. And supermassive. The recently discovered black hole falls into this category. To be amongst this group, the hole has to be more than 1 million times heavier than the Sun. 3. You can see the black holes with the naked eye. The reason black holes are black is that the gravitational pull at their center is so strong it consumes everything around it, including light. Because there is no reflection, we have no instrumentation that can detect the hole directly. So what scientists do instead is look for the traditional effects a black hole has on its surroundings. When a star is being pulled into the hole, it breaks apart and becomes distorted. As it's sucked in, the bits of matter from the star move faster, create intense heat, and throw off a glare of X-rays. That's what astronomers can use to identify a hole. 4. Black holes helped create galaxies. While astronomers aren't entirely sure yet what part the black holes have played in the creation of galaxies, one theory is that a large star exploded, a black hole formed, and the rest of the galaxy was created around it. 5. There is a black hole in the Milky Way. It is believed by scientists that there is a supermassive black hole in the middle of almost every galaxy. In fact, there is one at the center of the Milky Way, known as Sagittarius A. Because the pull of a black hole is so strong, you might wonder whether Earth is in any danger of being sucked into one of the supermassive varieties. Well, worry not. Sagittarius A, the Milky Way's black hole, is 26,000 light-years from Earth, too far away for it to affect us. Now, as developed in many science fiction stories, black holes could serve as getaways to other worlds, either distant parts of this universe or other universes entirely. But the reality might be more complicated than that. And outside of the sci-fi realm, dropping into a black hole is a bad idea. Even so, it turns out that people who enter a black hole would have at least a slight chance of escaping, either back into their own world or to some exotic place. This is because black holes actually bend space itself, and so could bring points that are ordinarily distant from each other much closer together. An oft-used analogy is the bending of a piece of paper. If you draw a line on the paper, it follows the paper's shape and the line's length is unchanged by bending the paper. But if you go through the paper, the end points of the lines are much closer to one another. Understanding this requires diving into Einstein's theory of relativity as applied to gravity. It's important to understand that a black hole is not empty space, but rather a place where an enormous amount of matter is shoved into a teensy tiny area called a singularity. In fact, the singularity is infinitely small and dense. There is actually some debate among scientists on this point, but it will take a lot of time. As one moves closer to the black hole, the escape velocity, the speed needed to escape the black hole's gravity, goes up. At a certain point, escape velocity is greater than the speed of light, or 186,282 miles per second, around 299,792 kilometers per second. For comparison, the Earth's escape velocity is about 25,000 miles per hour, around 40,270 kilometers per hour at the surface. Since nothing can go faster than light, that means nothing can escape a black hole. But there is a loophole. A black hole doesn't suck up everything around it, like a vacuum cleaner or bathtub drain. Its power extends only as far as the black hole's event horizon, whose radius is the distance from the center of a black hole beyond which nothing can get out. That radius gets bigger as more matter falls into the dense beast. Perhaps it's better to think of a black hole as a ball whose surface allows matter to pass inside, but never the other way. What's inside that surface is one of the biggest mysteries in astrophysics. Remember that most scientists think a black hole is a singularity. All the matter from whatever originally supplied the black hole's mass, a star for example, get crushed into a point that has infinite density. If you were to fall into a black hole, the usual description of such an event says that you would first get stretched into spaghetti by tidal forces, then crushed into nothingness. Your matter would then add to the radius of the black hole's event horizon. Eventually, you'd be emitted as Hawking radiation. Physicist Stephen Hawking's calculations showed that black holes give off photons. In doing so, the black holes lose mass, because according to Einstein's famous E equals mc2 equation, energy and mass are equivalent. Black holes eventually evaporate, but you would be waiting around a long time for that to happen. There is some debate in the scientific community about how long it takes for a black hole to evaporate, because the Hawking radiation doesn't preserve any information about the stuff that fell into the black hole in the first place. But the fact remains that being emitted as radiation is still not good. And what about wormholes? So, there might be a better way out of a black hole. So, gravity bends space. Think of a sumo wrestler rolling on the mat, indenting the mat with his weight. Any object creates a local gravity well. That well gets deeper toward the center of the object. A planet, for example, has a gravity well, but as you go toward the center of a planetary sphere, the well flattens out. Using the mat analogy, any normal object would have a well shaped like a depression with a finite depth. Black holes don't behave like normal objects, perhaps fortunate for the trapped individual. The curvature of space just keeps going up and up until you reach the singularity at the center of the black hole, where that curvature is infinite. Instead of a depression, you just have a hole whose sides get steeper as you go toward the center, until they are basically vertical and space is shaped like an infinitely stretched dimple. And that's why it's a mystery. Scientists use Einstein's theory of relativity to describe the curving of space, but Einstein's equations start to break down in the singularities of black holes. These singularities are also very small, and at that point one should see quantum mechanical effects. However, nobody has worked out a way to make quantum mechanical theory work with gravity to figure out what a singularity might look like. It gets even weirder when you realize that black holes aren't static. Realistically, any object in space tends to rotate. That means the singularity could, if it rotates fast enough, becomes a ring rather than a point. A ring singularity could provide a gateway to other universes, as in the 1994 sci-fi novel Ring by Stephen Baxter, published by HarperCollins. So a black hole could be a wormhole, a gateway through space and time. The idea is so intriguing because when you have a point singularity, no matter how you travel, the singularity is always in your future if you are inside the event horizon. But a ring singularity can behave differently. The part that crushed you into nothing doesn't always have to be in your future, because of the weird ways a ring singularity would bend and twist space and time. However, the concept of a ring singularity as a gateway is far from a sure thing. First, nobody knows how a ring singularity would come into existence. The other problem is that whenever people have tried to work out the mathematics of a black hole-made wormhole, they run into problems of keeping the gateway stable. Without a theory of quantum gravity, such questions are hard to answer conclusively. The other issue is that nobody has observed stuff coming out of nowhere, as one would expect if black holes could be gateways to other universes. After all, something would get through, even if by accident. One set of theories even proposes that black holes start whole other universes, causing other big bangs, and our own universe was one, but that idea is still controversial. And last, one implication of black holes as gateways is time travel. Because of relativity, there is no such thing as now that applies everywhere in the universe. Instant travel from point A to point B anywhere in the universe would also involve time travel, and you could end up arriving somewhere before you left. Physicist Stephen Hawking noted that since no one sees time travelers today, at least that's been reported, it seems unlikely that time travel is even possible in our universe. That would point to black holes being less useful as wormhole generators. So what do you think of that? Would you volunteer to explore a black hole in order to verify all these theories? Or more simply, could we send a probe or a robot in a black hole? But I start dreaming. Sorry. Are we living in a real world or in science fiction? Are you listening to the future DOZgeek or the present DOZgeek? Thanks for watching. Don't forget to like and share our videos. You can also subscribe to Section 51. Your support is really appreciated. I'll be back really soon. Open your eyes, watch the sky, live long and prosper.